So we talked yesterday about what the distributive property looks like, right? Where you have a number out in front of parentheses and that number gets distributed to both of our other numbers. What we're going to do with that is now we're going to bring negatives into that. So if I have something like this, -1 times x, what does it become? It's -1 times x. A negative x, right? Or a -1x. So we would say it's a negative x. So that means if I have something like this, okay, essentially what's happening is that negative is representing a -1. So you can, if you want, you can put a 1 in there. They're not going to put a 1 in there for you. They're just going to put the negative sign out in front, but it represents a -1. And then you would distribute that -1. And when you multiply something by -1, you always get the opposite of what it was, right? If you multiply x by -1, you get the opposite of x, which is -x, okay? So that's what we're going to do here. -1 times x would be a -1x, which you can just write as -x if you want. If you want to write it as -1x, I'm okay with that right now. But I'd prefer as time goes on that we just get in the habit of leaving that 1 out, because the simplest way to write it is just -x, okay? So that's going to be -x. And then we're subtracting, so we're going to put that minus sign in. What's -1 times 6? A -6, right? So it's -x minus a -6. What does that become? Plus a positive, right? Minus a negative is always plus a positive. So it would be -x plus 6. So look at this and look at this. Okay, we started with x minus 6, and now it became the opposite of that just because we had that negative out in front. So a -x and a positive 6, where it was a positive x and a -6. Okay? So you're just taking the opposite. So let's do a few of those. This is like example 3. So if I give you, for this first one, a -2y minus 3x, okay? Essentially, that's like a what out in front? A -1. Okay, so if you want to put the 1 there, put the 1 there. If you don't care, you may leave it off. It's just whatever makes more sense to you, okay? Who would put the 1 in? A few of you? Okay, so if we were to put a 1 in and distribute this, what does that 2y become? -2y. Okay, and then we're subtracting, and then it's -1 times 3x would be what? A -3x. So that would be plus a positive. So it's a -2y plus 3x. Okay, now here's the deal. You could think of this right now as a -3x, so that when you do a -1 times a -3, it becomes a positive 3x, which is plus 3x, okay? People look at it different ways. It's whatever makes sense to you. If you want to leave it as the sign and then a minus a negative and change that to plus a positive, you totally can, okay? Questions on that? All right, what is this? A negative a plus 5. If we distribute that, what do we get? What do we get? -1a, which we're just going to call -a. And then what? Okay. Plus -5, or you could say minus +5, right? So we're adding. When we distribute that negative, it would be plus a -5. So you can write it as -a plus a -5, but even more simplified than that would just be to say -a minus 5. Okay? Either one of those is fine. I will take either one. Yeah, Jada. That negative is what's going to switch it. So if there's a negative out in front being distributed, that's going to switch your number from what it is to the opposite of what it is right now.
Okay, So if it was positive.
It'd become negative. If it was negative, it would become positive.
And if it wasn't no negative or positive in front, then it's just.
If there wasn't a negative out in front, then the signs would stay the same. If they were positive, they would stay positive. If they were negative, they would stay negative. Okay? Okay, how about this one? All right, so this is our setup, a negative 6m minus 9n. Okay, so if I distribute that negative, what does that 6m become? A negative 6m. Okay, and then I distribute the negative here. So right now you can think of it as negative 9n. So it would become what? Positive 9n. So you could do plus 9n, or if you prefer it, you could think of it like this. Negative 6m minus a negative 9n, right? But then you're going to turn that into plus a positive. So either way, it's going to end up like this. But if you want to start as minus a negative and then change it from there, that's fine. Was that a hand up, Jada? Just stretching. Any questions on that? Okay, so the next thing we're going to talk about, there's four definitions that I'm going to give you. So you might want to write these down just so you have them, keep them straight. The first is a term. Can anyone tell me what a term is? Do you know? Okay, I will tell you. It's a number, a variable, or a combination of those two. So we're not going to say or a. We're going to say or the product of both. What's product again? Multiplication. So if I multiply a number and a variable or multiple variables, that will still be a term, okay? So some examples of that. For instance, the number 7, okay? That's a term. The variable x is a term. Or I could say 3xy is a term because I took a number and variables and I multiplied them together, okay? So those are all terms. The next thing we're going to talk about is a constant. Okay, and a constant is the term that has no variable with it. So it's the term that has no variable. So my constant in the example above, up here, which one is the constant?
7.
The 7, right? It has no variable attached to it. It's just the 7. So the number 7 is a constant, or the number 24 is a constant, or -3 is a constant, okay? In an expression, it would be something like this. So if I did 2x plus 3, my constant is that 3, right? If I said 4xy minus 2x plus 6, my constant is that 6. If I said 4x minus 9, my constant is actually a -9. Okay, so it's the one that doesn't have the variable with it. It can be positive or it can be negative, but that is our constant. Okay? Anyone know what a coefficient is? Coefficient. The coefficient is the number that comes before a variable. So number that comes before a variable. Okay, so if I have like 3x plus 2y plus 7, okay? My coefficients right now would be this 3 because it comes before the x, and this 2 because it comes before the y. So 3 is a coefficient to x, and 2 is a coefficient to our y. Questions on that? Okay, so I'm gonna just give you kind of a combination of all these things, and we're gonna talk about what is what, okay? So if I have 6a squared plus a negative, 5ab plus 3b plus a negative 12, okay? My terms right now, how many terms do you see? How many is it? 4, right. There are 4 terms. So this right here is a term. And this is a term. And this is a term. And this is a term. Okay, so we have 4 terms in this problem. How many constants do you see? 1. And there's typically only 1 constant. Sometimes there isn't even a constant. But our constant is this guy here. The negative 12 is our constant. Oops. Okay, so negative 12 is the constant. And then how many coefficients do you see? There's 3. So 6 and negative 5 and 3 are all coefficients. Okay? Any questions on those? All right, my question for you then is, do you know what like terms are? Do you know what it means when we talk about like terms?
Isn't it like
The same what?
variables?
The same variables and exactly the same variables, right? So like, well, let's just write this out. Like terms. Okay. We're just going to write same variables for this, and then we'll give a few examples. So if they have the same variables, that's like, we would say 7a and 3a are like terms, right? They both have a as their variable, okay? Or I could say 4x squared and 12x squared are like terms because they both have an x squared, okay? So these are like terms, okay? Some that are not like terms would be something like 6ab and negative 2a. Notice the difference. This one's ab, this one's a. Those are not like terms. Okay, or maybe it's x squared y and xy squared. It has all the same numbers, all the same variables involved, but one is x squared and one is y squared. Those are different, so those are not like terms. Okay, questions on that? Okay, so we're going to do a few problems where we simplify and we combine like terms. So your most simple answer always is when all of your like terms have been combined. So you don't want any x squared with another x squared left in a problem. You want to put those x squareds together, okay? So that's what we're going to do right now is we're going to combine like terms. So this is like example 5 in the book. We're skipping over 1 right now. But they're just going to tell you to simplify by combining like terms. So let's say my first problem is 8x squared plus 2x squared. Okay? Here's what I tell people. Your variables are like an object. Okay? So x squared, if you replaced it with the word apples and then you spoke it, it would make a lot of sense what your answer should be, right? So if I said 8 apples plus 2 apples equals how many whats? 10 apples, right? Your apples didn't change. Your apples were still apples. So 8x squared plus 2x squared is 10x squared. You don't make it x to the 4th. Did you hear me on that? Don't make it x to the fourth, okay? This is like apples. You leave it as apples. So basically what you're doing is 8 plus 2, and then multiplying by our x squared, which becomes 10x squared. Okay? So you're combining the like terms, leaving your terms as what they were to begin with. What would you do for this one? If I give you 5x minus 3 minus 3x plus 6y plus 4, okay? First thing you might want to do, and if you are a color coordinator like I am, you are welcome to color coordinate to your heart's content here, okay? What I would do on this is I would get out a highlighter and I would shade the things in the same color that are like terms, okay? So if I have 5x here, do you have any like terms to that 5x? What? Right, which is technically a negative 3x because we're subtracting it. Okay, so for me, I would shade those both yellow. Okay, then I would get out my other highlighter and I would see if there's anything else that can be shaded the same color. Do you see any other like terms here?
3 and 4.
The negative 3 and the positive 4, right? Those are like terms. Does the y have a like term? It doesn't, okay? So what we're going to do is we're going to rewrite this problem so our like terms are together. So I'm going to do 5x minus 3x. We always put the constants at the end, so we're going to do the y next, plus 6y. And then we have minus 3 and plus 4. Okay, so now it's in the order that we want to simplify in. Now we just simplify. So 5x minus 3x becomes what? 5x minus 3x. 5 apples minus 3 apples is 2 apples, right? So this is 2x plus 6y we can't do anything with, so we're going to leave that as 6y. And then how do I simplify my constants? Negative 3 plus 4. Positive or negative? Positive, right? Because my bigger number is positive, so negative 3 plus 4 is a positive 1. So this is our most simplified version of it. Does that make sense? Okay, let's do another. How about if I have 3y minus y? What does that become? 2y, right? Essentially, you have a 1 here in front of that y. So 3y minus 1y is 2y. Okay, don't get rid of your y's. It's 3 apples minus 1 apple is 2 apples, right? How about this one? 7y to the third z minus 6yz to the third plus y to the third z. Okay. Do you have any like terms?
Yes.
Which ones?
7y to the third z and y to the third.
Right. So this one and this one are the same, right? This one's different. So don't lump that one with it. That's z to the third. The other one is y to the third. So what we're going to do is we're going to rewrite it. So it's going to be 7y to the third z plus y to the third z minus 6y z to the third. Okay? What does this work out to? 7y to the third z plus y to the third z. 8y to the third z, right? This is 1 out in front, so 7 plus 1 is 8, y to the third z. Okay, and then this part we can't simplify, so it's just going to be minus 6yz to the third, and we're done. Okay, we can't combine any further because they're not like terms at that point, so we're just done. Questions on that? Okay, last one. What if I give you 8x squared minus 2x to the fourth minus 2x plus 2 plus xy? Okay, do you have any like terms?
8x. Wait, no.
There are no like terms here. Okay, but here's the deal. There is a better way to write this because we always put the constant at the end, and then we always put the exponents in descending order. So the biggest exponent going down to the smallest exponent, okay? So our biggest exponent right now is here. What is that number? Negative 2x to the fourth, okay? Make sure the negative comes with it. So negative 2x to the fourth. Okay, so this one's done. What would come next? 8x squared, so that's a positive, so we're going to say plus 8x squared. Okay, so we're done with that. What would come next? Technically right here I would say you could do either. I would do the negative 2x and then plus xy from there. Just because these are all x's, so I would just keep going in that x routine. And then the plus xy, and then your last thing should be that plus 2. Okay, so when you write out an expression like this, put the exponents in descending order and put the constant at the end by itself. Okay, questions on that? All right.